Hello again, Algebra fans. Welcome back to Southwood's Algebra 1 videos. Today, statistics, univariate data, how to organize your univariate data with central tendencies. This is part 1 of a 2-part series. Here we're presented with some real-world univariate data. Daily high temperatures in a mountain town for 28 consecutive days. This looks like a real mess, but let's organize it using Desmos. I can enter my list of univariate data in one of the equation bars in Desmos. Make sure you give it a name. I just call it capital L equals, and I use the square brackets, which are on the right side of your keyboard, and I just list all 28 elements. So you can see here they are. And it tells you there's 28. So if you missed any, you have to go back and check. Then you can open up down in the lower left-hand corner, it says Show Keyboard. Go to Functions, which is on the right side, and it will give you, if you scroll down a little bit, all the statistics functions you need. The mean, the median. Here you type in, you hit the mean, and then make sure you type in the name of the list you want in parentheses, parentheses L, and you can see it gives you the mean. Same thing with median. It doesn't give you the mode, unfortunately, but if you go to List Operations, Sort, it will give you all 28 elements in order from least to greatest. Then I can clearly see that 55 is represented 5 times, which is more than any other element. If you also look down the statistics menu, it gives you stats, which are the 5 statistics you need for the box plot: the min, the first quartile, the median, the third quartile, and the max. You can also find standard deviation under statistics. Make sure you type standard deviation as STDEV, this button, not the one next to it, and then parentheses L. This gives you the average distance from the mean. You can also represent a box plot, a dot plot, and a histogram under here where it says visualizations. We'll get into those later. But right now, basically, I can answer most of my worksheet just by copying these statistics that I get from Desmos into my worksheet. Here are the statistics that I got from Desmos. I had to round my mean to the nearest whole degree because it was very close to 57 degrees, but it's not going to be exact. My median was 55.5 degrees and my mode was 55 degrees. Now, if you notice, my median and my mode were a little bit less than my mean. My mean got pulled a little bit to the right or greater than the median and the mode. That's going to be important later when we look at the graphs. My range is 20. All I did was subtract the max and the min. And my interquartile range, I subtracted Q3 minus Q1. I made a distribution frequency table by using the sort elements that I got when I sorted. I just counted up how many elements were between 45 and 49. There were 2. There were 7 between 50 and 54. There was 10 between 55 and 55. That was my modal interval. And indeed, my mode was 55. But so on, I can use that information. I can use this table to make a histogram. Now, when you look at your dot plot, your box plot, and your histogram, when we do them later, notice that although originally I thought the data might be normal, when I looked at the mean compared to the median and mode, I noticed that the mean was a little bit to the right of the median and the mode, meaning it was skewed slightly right and not completely normal. So the histogram, dot plot, and box plot are in this menu, Visualizations. Here's the dot plot. In order to set your domain, go to this little wrench in the upper right-hand corner and set your X. I started my X at about 41, and I went all the way to about 81 to make sure that I got my minimum and my maximum. The Y's, I needed to get at least to 5 because I knew that was the mode. And here's what my dot plot will look like. For the box plot, you want to check this box that says Exclude Outliers. Now on this box plot, in this set of data, there was no outlier. But let's say that I put in another element, 80, that I think might be an outlier. Yep, and there it is. If you click this box, Exclude Outliers, you'll see that the element that I just added, 80, is actually an outlier for the data set. It will fall outside the upper bound of the outlier formula. Then here's your box plot. To construct a histogram, you have to tell Desmos how wide or how much width you want to give each bar. In this case, I want to go along with my frequency distribution, which included 5 numbers in each width. So each bar is going to be 5. So when you type in your histogram and your L in parentheses, make sure you comma 5 to tell it what the bar width is going to be. Also, make sure that your bin alignment is to the left. That means you're going to start each interval on the left, not the center. So here's your histogram. Notice on my dot plot, I can see the skew. There's a tail slightly to the right. The tail is where the skew is. If more of the data is to the left, that means that the mean got pulled a little bit away from the mode and the median, which should be down the center. It's not too bad, and I almost thought by looking at the data that it was normal, but it definitely does have a little bit of a tail towards the skew to the right. Here in my box plot, you can see the way the data is distributed. There's 25% of the data between each of the 5 critical statistics. The min and the first quartile have 25% of the data. The first quartile and the median also contain 25% of the data. Even though there's a larger space between the median and the third quartile, that's 25% of the data. And even though the third quartile to the max seems to have a slightly longer tail, that also contains 25% of the data. Meaning, I have data that's slightly skewed to the right because there's more space between the median and the max than there is between the min and the median. So this is definitely a skew on the right side. We call that skewed right. And quickly looking at the histogram, it's not quite as apparent, but here where the median is, or the median interval is, or the modal interval as well, the mean is pulled a little bit to the right, and you can kind of see the skew here. So it's skewed a little bit to the right. You might be fooled into thinking it's normal, but it really is skewed a little bit to the right when analyzing all the graphs. So this video dealt with univariate data. Remember, univariate data is one list of data, and all we can do with that data is analyze and organize it. We can make a dot plot, we can make a box plot, we can make a histogram. Most of our data was fairly normal, not really skewed to the left or to the right. In the next video, we'll talk about scatter plots. Scatter plots will be used to compare two lists of data. Until then, see you next time.